everybody. Welcome to Chapter 6. In this chapter, we will learn more about metals, ceramic, and polymer. This Chapter 6 are prepared by Nuramirah Ainaa, Nur Zatulhusna, and also Nur Hazni. I hope you enjoy. Hello everyone, I'm Ainaa. Nice to meet you. In this chapter, we are going through more about metals, alloys, and iron. So now, I'm gonna go more about metals. Before that, I'm going to introduce two of my friends, Nini and Nana. Hello, I'm Nana, and that's Nini beside me. Hello there. Now, we will learn about metals. Let's go! Nini, have you ever wondered what is metal and how it forms the sea of electron? You know, when we talk about metals, we are usually referring to chemical elements that are solid, right? Yes, I know, Nana. The electrons from the outer shells of metal atoms are freely moved around, and that's how it formed the sea of electron. Yes, exactly, Nini. Good job. But wait, Nana. Can you list what are the characteristics of metals? Yes, indeed, Nini. Metals have high density, reactive metal, ductile, good thermal, and good electric conductor. Not to forget, metals are high melting point and elastic modules too. Besides, alloy and metals are very useful in engineering properties. Wait, what about alloy? What is alloy? I don't understand. Help! It is a metal made by combining two or more metallic elements that gives greater strength and less corrosion. Iron and alloys account for about 90% in world production of metals due to better strength, improved toughness, and its ductility. Do you know that metallic materials have two types of alloy? Yes, they are ferrous metal and alloys and non-ferrous metals and alloys. Ferrous metal contains large percent of iron, such as steel. Meanwhile, in non-ferrous metals and alloys, there is no iron, and the examples are copper, zinc, and aluminium. You are right, Nana. It seems like ferrous alloy metals are better than non-ferrous alloy, right, Nana? However, there are several advantages and disadvantages too. True, the advantages are iron ores exist in abundant quantities. The extraction, refining, and fabrication techniques are economical. It is recyclable and environmental friendly, very magnetic, and also high strength to weight ratio compared to non-metals. For the disadvantages, it is very susceptible to corrosions. It has high relatively density, and lastly, relatively low electrical conductivities. Not to forget, there are also effects of carbon on the steels. When the carbon increases, the hardness and strength will increase, which leads to low ductility and less easily welded. Seems like we're almost done about metal. Good job! Before that, what's the difference between cast iron and rough iron? Another questions, Nana. When can we end this? Iron casts have 2 to 4% carbon content, which are great for the environment. It can also recycle and does not rust. However, it is strong in compression but weak in tension since the structure is crystalline and brittle. Rough iron have very low carbon content compared to cast iron, but it is flexible, tough, malleable, and easily welded. Yay! It seems like we are done now with metal. Phew! Yeah! Let's move on to Zato for more infos. Bye bye!
Hi, I'm Zatulhusna. Now, we will learn about non-ferrous metal and alloys, thermal processing metals including annealing and quenching process, and all about ceramics. And yes, today I'm not alone. We will learn together online with the help from Professor. Hi everyone. Today, Professor will explain to you about the non-ferrous metal and alloy. This metal possesses low strength at high temperatures, generally suffer from hot shortness, and have more shrink than ferrous metal. Besides, these metals are widely used in the industry as they have really good properties such as high corrosion resistance. Besides, they are really easy to fabricate, including for machining, casting, welding, forging, and rolling. They also possess a very good thermal and electrical conductivity, plus they have really attractive color and low density. Professor, what is the difference between ferrous and non-ferrous metal? A ferrous metal alloy is a metal which composition contain mostly iron, while a non-ferrous metal is a mixture of two or more metallic elements that does not contain iron. Professor, another question. What is the meaning of hot shortness? Thank you. That's a good question. Hot shortness is a tendency for some alloys to separate along grain boundaries when stressed. Okay, student. Now, let me ask you back. Can you identify the type of non-ferrous metal and alloy? Yes, Professor. Examples of the non-ferrous metal are aluminium, copper, lead, nickel, tin, titanium, and zinc, and alloys such as brass. Okay, student. We will continue on the thermal processing of metal. What is that? Thermal processing of metal can be used to control microstructure and mechanical properties of metal alloys. Under this process, we will cover on the annealing process and quenching process. Okay, student, what is annealing process? Annealing is a softening process in which metals are heated above its upper critical temperature for an extended time period. Then, it is allowed to cool at room temperature at a relatively slow rate. The stages of annealing include heating to required temperature, holding at constant temperature, and cooling. This whole process can change in microstructure of the metal to improve machinability and formability. So student, what are the purposes of annealing? As I said before, that this whole process is to change the microstructure of the metal. Thus, it will improve the characteristic of the metal. First, the purpose of annealing is to relieve the internal stress, which can avoid distortion and cracking. Second, it improves the machinability, which is softer and make it more ductile and easier to machine in the machine shop. And lastly, to refine the grain. After some types of metal working, particularly cold working, the crystal structure are elongated. Annealing can change the shape of the grains back to the desired form. Okay student, let's move to the quenching process. What is quenching? Quenching process involves the rapid cooling of a metal to adjust the mechanical properties of its original state. To perform the quenching process, a metal is heated to a temperature greater than its normal conditions, typically above its recrystallization temperature but below its melting temperature. Plus, the quenching process stops the cooling process from altering the metal microstructure, and mostly it is applicable to steel. Professor, I'm still confused. Can you give me an example of situation between the annealing process and quenching process? Okay student, imagine this. When you take an untreated piece of steel, then you put it in a furnace to raise its temperature to a single phase, and after that you turn off the furnace and let the piece of steel to cool inside the furnace. Then the process is known as annealing. For quenching, it is a simple process when generally it's a cooling process, faster cooling like dipping in water, lime solution and oil. Anyway, Professor, what is the purpose of quenching? Good question. So the purpose of quenching is to bring the metal back to room temperature after heat treatment to prevent the cooling process from dramatically changing the metal microstructure. Okay student, now we will learn about ceramics. Ceramics are inorganic and non-metallic group of material which ingredients are clays, sand and feldspar. The common chemicals bond for ceramics are ionic or covalent bonds. Ceramics are good electrical and heat insulation pro, and it have properties such as low density, high melting point, very high elastic modulus, unreactive and brittle. There is a lot types of ceramic which are glasses, clay-based, engineering ceramics, cement and concrete, rock and minerals, ceramic composite, and new engineering ceramics like carbides, nitrides, and borides. Okay, student, now I will explain about each of the classes of ceramic. First, the traditional ceramics are also known as clay or hydrated aluminum silicates. Usually, traditional ceramics are used for building bricks, sewer pipe, drain tile, and roofing tile. For engineering ceramics are also known as advanced ceramic. Example, we have oxide, carbides, nitrides, alumina, silicon nitrides, silicon carbide, zirconium composite. These advanced ceramic are used in the application of aerospace and also in the automotive, which in the valve component. Glasses are also the classes of ceramic. There are non-crystalline silicates containing other oxide, and glasses are widely used in the application of containers and lenses. Most inorganic glasses can be made to transform from a non-crystalline state to one that is crystalline by the proper high-temperature heat treatment. Most common uses for these materials are ovenware, tableware, and oven window. Next is clay. One of the most widely used ceramic raw material is clay. The whiteware ceramics become white after high temperature firing, and the application of clay usually are for porcelain, pottery, tableware, and plumbing fixtures. Moving on to the refractory material. A refractory material is a heat-resistant material. Example, a mineral that is resistant to decomposition by heat, pressure, or chemical attack. Most commonly applied to a mineral that retains strength and form at high temperature. Example are silica oxide, alumina system. And last one is the abrasive. It is used to wear, grind, or cut away other materials. Diamonds, both natural and synthetic, are utilized as abrasive. However, they are relatively expensive. The more common ceramic abrasives include silicon carbide, tungsten carbide, aluminum oxide, and silica sand. Next, the fabrication of ceramic. This process takes place through powder metallurgy techniques. The basic steps for this process include: first, raw material preparation; second, forming and shaping; third, thermal treatment by drying and firing; and the last one, the final forming. For the thermal treatment of ceramic, it includes two processes, which are drying and firing. For drying process, it is to remove water and is carried out at or below 100 degrees Celsius. As drying process takes place, water will be removed and the interparticle spacing will decrease. Thus, the layer size also will decrease. However, drying too fast causes sample to warp or crack due to non-uniform shrinkage. Second, the firing process. This process usually took place at temperature raised to 900 degrees Celsius to 1400 degrees Celsius. Okay student, before we finish this part, do you have any question? Yes sir, I have one question. What is powder metallurgy technique or PN technique? Good question. Powder metallurgy technique is a value-added engineering process for forming metal parts by heating compacted metal powders to just below their melting points. This technique is a heat treatment and called sintering. Professor, I have another question. Why drying process of ceramics? Drying is a critical stage in ceramic manufacture. The drying process sometimes places more stress on the ceramic pieces than during firing because the drying needs to be done slowly to prevent warping and cracking of the green body pieces. Sorry, Professor, I have one last question. Can you explain more about ceramic firing process? Sure. Firing converts ceramic work from weak clay into a strong, durable crystalline glass-like form. Ceramic work is typically fired twice, first by beast fire and then glass fire. As temperature in a kiln rises, many changes take place in the clay. Okay student, I think that's all for this part. Thank you for your commitment, and if you have any question, feel free to ask.
Okay, now let's proceed to the mechanism of the sintering. Sintering occurs during firing of a piece that has been powder pressed. And then during the initial stage, the necks form along the contact regions between adjacent particles. A grain boundary forms within each neck, and every interstice between the particles become pores. You can see from the diagram side. And then the sintering progresses, the pores become smaller and more spherical in shapes. Okay, now for the vitrifications. Some ceramic products such as porcelains contain a glass phase. When the ceramic is a fire, a process known as vitrification takes place whereby the glass's phase liquefies and fills the open space between the particles. When the body cools, the glass solidifies and acts to bond the unmelted particles together. Now to the introduction of the polymer. And most polymers are hydrocarbons made up of hydrogens and carbon. The properties of polymers have a very low density. It has a low melting point, low elastic modulus, and a dark glass and brittle types. So here from the polymer have two types, this is plastics and elastomers, while the plastics have two types, is thermoplastics and thermosetting plastics. For the elastomers rubbers, a natural or synthetic polymer whose dimensions can be greatly changed when stressed and that returns to its original dimensions when the deforming stress is removed. For the vulcanizations, a process which the polymer's molecules are joined together by the cross-linking into larger molecules. Then the heating rubber with the sulfur. This process leads to restrictions of the polymer change. Movement thus makes the polymers much more harder and stronger and more or less elastic. Hello everyone, today I'm going to talk about plastic. Well, plastic can classify in many different ways, such as chemistry, structure, and lastly, behavior. And now, as we proceed to the polymers of the plastics, it can be either way, the thermosets and thermoplastics. For the common example of a thermoset, like these shoe soles and a sponge. While and for the thermoplastic, example like these spectacles, glass casings, and the talcum bottles. Okay, now let's talk about a thermoset. Okay, in thermosets, when they heat and cool, a process called curing or set occurs that gives it a permanent set of shape. Once the thermoset are cooled and hardened, it cannot be melted again. Instead, it will be burned when we try to heat it. You can think of a thermoset responding to the heat in the same way to the egg does. When you heat the egg, it hardens and becomes permanently cured. Once you cook it, no again back to the real form. And now is a thermoplastic. Thermoplastic like this plastic toy. It softens and melts when you heat them. But what the good things about thermoplastic is this: it can be reheated and shape the melted plastic and make it in a new form of a plastic. Thus, this is different from the thermoset which cannot be remelted and reshaped. You can think of thermoplastic like an ice. We can heat up the ice cube, melt it, and cool it back down to fit any shape you want. And why does this happen? When thermoset is heated, the polymer change and begin to attaching to each other. The process are called cross-linking. The cross-link gives the thermoset a permanent 3D structure and make them more resistant to melting. While for a thermoplastic, it is do not cross-links when heated. Instead, a polymer change to thermoplastics become fluid and can slide past each other, which causes them to melt. This makes it easier for thermoplastics to make any form we want. Okay, for example, like this plastic. Thermoset is also make it easier for thermoplastic recycles. It can easy to recycle back. Okay, now for the quiz. Would the plastic bag be considered to be a thermoset or a thermoplastic? And how about the cartonier? The plastic bag melts when heated and can be recycled, so it is a thermoplastic, while for a tire, it's heat resistant and can't be melted, so they are thermoset. Alright, okay, that's all for me. Thank you and hope you enjoy.